So in this session, we are going to see recursion, command line arguments, variable length arguments. One by one we shall see. So we have seen normal program for calculating factorial. So this could be a best example for understanding recursive functions. But basically any program that is having a repetitive jobs, looping, okay, involved, that can be reprogrammed with recursion. Okay, so this is a normal recursive program, normal factorial program, and that is converted to as a recursive function here. So inside the class, fact is a method that takes one integer parameter, and if n equal to 1, it returns 1. Otherwise, it returns fact of n minus 1 into n. So first time, for this n, 4 is stored, and n minus 1 becomes fact of 3. So it goes inside and it comes here, and one by one it will check. So next time 3 will be there, next time 2 will be there, then finally 1. All these are multiplied together. So these recursive functions, the intermediate values, okay, because the same function calls itself again and again. These intermediate values are stored in a stack. So first 4 is stored inside the stack, next 3 is stored, next 2 is stored, and then 1. And finally, nothing else, everything, the complete function is returned. Over means one by one all these values are taken out and multiplied. First one is taken out. So you all know stack means last in, first out. So finally we entered 1 inside that. So 1 into 2. Then with the result value 2, the next value inside the stack 3, that is multiplied. Then 2 into 3 becomes 6. With that 6, next 4 is multiplied. So it gives us the result as 24. If I give 4 as the input. So let me run this. You could see this is giving the result. So one more time I am running this. This time I am giving 5 as input. It is giving 120. Okay. So this is how recursive functions are working. Okay. So you can remember intermediate results of recursive functions are stored in a stack. Okay. So next is command line arguments. Command line arguments are arguments that are passed during execution. While executing the program, running the program, some values are passed as a parameter for main method. Those are called as command line arguments. Okay. So this is one simple program. You could see normally if I have a main and I am having one variable, integer variable, and I am printing that x into x. Okay, so this is a very basic program and I am running this. It is printing what I am giving. Okay. And if I am trying to print the argument of main. Okay, so you could see what is the argument of main. This is the argument, string array. So the array name is args. Okay, so I am trying to print args of 0. Now I am trying to print. I am not passing anything. Normally I am running this. Okay, how a normal Java program that I run. Oh, parameters are already set. Okay, so how we are setting the parameter. So whenever command line argument is supplied, so we have to give run configuration. In Eclipse, we have to give like this. So arguments, I should give welcome to Java. So these are the program arguments. Okay. So each will be considered as a string. Welcome to Java. So 3 string values I am passing as argument to main. So you could see command line arguments. Okay. So now I am running this means it is printing first argument as welcome. And I am printing second argument. And next 0, 1, 2. 3 arguments I am trying to print. Now it will print all the values one by one. A of 0 is welcome. A of 1 is 2. A of 2 is Java. Okay. So I can also access this using for loop. So you could see the for each style for loop we can use. Normal for loop also we can use. string MSG. This is the local variable. Okay, for this for loop. MSG colon ARGS. All the elements in ARGS will get printed one by one. So now I am running this. You could see, welcome to Java. All these are coming. So now I am deleting that command line argument. I am deleting. Okay, so here I am deleting it. So now if I try to run this program, I am not supplying anything. You could see it is telling array index out of bounds exception. Okay, array index out of bounds exception. So ARGS of 0, 1, 2. I am not supplying any values for this. So no values are there, no array is initialized, but I am trying to use it. So it is telling array index out of bounds exception. But this value is coming. Okay, after this line, it is throwing exception. So these are command line arguments. Okay, sometimes we need to pass values to the main also. Okay, so in Eclipse, to pass arguments to main, we will be giving it in this arguments field here. Any number also I can give 1, 2, 3. Okay, each will be treated as a string. Though I am passing it as numbers, it will be treated as strings. Okay, so now I am running this. You could see first is 1, second is 2, third one is 3334, 3334. Okay, anything we could pass, but it will consider everything as a string. And if I want to convert this into integer, means after taking this, I have to manually convert that. Okay, so parseInt method is there. We can manually convert that string into integer value. Okay, in that way we can use it. So this is about command line arguments and variable length argument. So this is one important thing. Variable length arguments are useful when for one student he completed 6 subjects in a semester. For another student he exempted one elective course and he completed only 5 subjects. I need to have one average calculation function. Okay, so for some students I will be passing 6 marks. For some students I will be passing only 5 marks, 5 subject marks. So accordingly, it has to calculate the average. Okay, only one average function or some methodology I should follow. It has to do average. Like 6 subjects I am passing means it should divide by 6. 5 subjects I am passing means it should divide by 5. So likewise, automatically it should take the value, how many number of subjects are there. Okay, so for that, what could be the solution? We can do method overloading. Average function with 5 mark values and another average function with 6 mark values. Likewise, I can do. That is one solution. And another solution is adding the mark values into an array. So in that array, 5 elements are there means all the array elements will be taken for average and it will count how many elements are there in the array. Array dot length will give us the size of the array and we can divide that, isn't it? And the difficulty here is, this is a good solution, but the difficulty here is every time all the marks I have to pack into an array, then I can pass, isn't it? So I need to create one array, add all those elements in the array or initialize the array, then that array should be passed as an argument. But instead, is there any other solution? Yes. The solution is variable length arguments. Okay. So how do we create variable length arguments? So you could see this is the example of variable length argument. Double dot 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 mark. So for the student, I am giving int roll number, string name, and he may have 4 subject marks or 5 subject mark or 6 subject mark. For that, I need to calculate average. Okay, so this average function takes roll number, name of the student, and list of marks. So this is the syntax for using variable length argument. instead of giving it as an array, I can give it as a variable length argument. Okay. So once this is given here, in the main, I could pass like this. So roll number 1, Arun, 2 marks only. He completed 2 subjects only. So I am passing 2 marks. For this, average is to be calculated. And for the next student, roll number 2, Tarun, 3 subjects he completed. So I am passing 3. And roll number 3, Sam, he completed 4 subjects. For all the 4, average is to be calculated. So I am using the same average method. Okay, only one method I have, same average method. Okay, so for that, I am giving different set of arguments. Okay, variable length arguments. For this, totally 1, 2, 3, 4, 4 arguments. And for the second one, Tarun, 1, 2, 3, 4, 5. 5 arguments are there. And for this, 1, 2, 3, 4, 5, and 6 arguments are there. Okay, so all these will come here and it will initialize the result value to 0 and it prints roll number and name and initialize for loop to calculate the total and then average. So to calculate total for I equal to 0, I less than mark dot length because this is mark. So internally the compiler considers this variable length argument as an array. We don't need to pack these values into an array. Simply I can pass these values, individual values. Compiler automatically composes it as an array and it is stored in mark. So mark dot length I can apply, then I plus plus result plus equal to mark of 5. So all the marks are added. Then after the loop I can divide result divided by mark dot length. Only 2 marks are supplied, result by 2. 3 marks are supplied, result by 3, likewise. And this value is returned. That I am printing here. 2 marks average, 3 marks average, 4 marks average. Okay. So this is how variable length arguments can be used. And moreover, this method can also be overloaded. So you could see, so here I am having one integer, one string and a double variable length argument. So another method I am having average and it takes only one double value. Okay. So likewise, I can overload this. One more average like int average int variable length argument mark. Okay, so this is also variable length argument, but integer only. So in that way also I can overload this. So here also I can use. Okay. The only thing is this is taking only mark. Okay, roll number and name, not this. It is not taking. So what should I do? Int result. Okay, so it returns result. So in that way I can overload this operator also, like by distinguishing this argument also. But the thing is, while overloading, I should not create any ambiguity for the compiler. Like I am overloading like this, average int x. So you could see this will create an ambiguity because one int, any number of int can be supplied here. So one int will also match here, 2 integers, 3 integers, 4 integers, 10 integers, 20 integers, anything can be matched with this. And I am having one more with one integer. So compiler will get confusion when only one integer is passed, whether to match with this function or with this function. So that sort of ambiguity should be avoided. Okay, so this is not possible. So I am commenting this. Okay, I hope you got this. So we can overload by differentiating this variable length argument also, but we have to be careful. There should not be any ambiguity. For any data type, we can use this variable length argument. For Boolean also, I can use. Okay, double, float, int, short, byte. For everything, we can use this variable length argument. So that will work perfectly. One more thing is, you can ask me, ma'am, first field I am giving this as first argument, variable length argument as the first field. Then roll number, then name. Will it work? No, it will not work. So you could see it is reporting an error. Variable argument type should be the last parameter. Okay. So that is the only parameter, means here I am giving that as the first parameter. But more than one parameters are there, then that should be given at the last. Okay. So that restriction is there, that also you should remember. Okay. So in a method, we are including variable length argument, means that should be the last parameter. Okay. And I should avoid giving like this, int mark, int x comma int mark. So what will happen in this case? This itself takes the number of integers and I am giving one more integer. So this is meaningless, isn't it? So that sort of code also to be avoided. Okay. So I hope you got what is variable length argument. Okay. So this new feature is included from JDK 1.6 onwards. Okay. So it simplifies creation of methods that need to take several arguments. Different time, different set of arguments. So in short, it is called as Varargs. Varargs. Variable length argument. Varargs. Okay. So any method that takes variable number of arguments is called as variability method. Variability method. Okay. Or Varargs method. So you could see these type of things we should avoid. It leads to ambiguity. So this is about variable length arguments. And next we shall see access specifiers. So access specifiers deals about what access control keyword we are going to give: public, private, protected. Default means no keyword. Okay, there is no keyword called default, but nothing. I am not giving anything. Simply int x means it comes under default category. Okay, so Java provides encapsulation of any program using the concept of data and methods. Okay, data is accessed through the method. So likewise, we can use this access control also one way of provisioning encapsulation. So we can restrict this particular data is accessible only through the method. Okay, outsiders cannot access that. So that is one way of providing that. So we could see the stack program, what we have seen already. I'm taking that program. Stack 1, stack main. So in this stack program, I didn't give any access specifier here. Private, public, nothing I give. Okay, so this is coming under default category. So default category means, you could see here I am initializing the array and the array values are used here. ARR, AY, array of top. Okay. And from main, I am simply calling push and pop. This is encapsulation. Through the method only, I am accessing the values of stack. The stack variable is an array. Here, this is the instance variable for this stack class, and this is assigned value only through the push and pop methods. I am not directly using anything. But if I try using, what is the name of that? ARR, AY. So using the object, if I am trying to access something, for example here, I am giving system dot out dot println array of 2. Array of 2 value is, I could give s1 dot array of 2. Okay, you could see it is not reporting anything. Outside the method also, I mean, not through the method, directly I am accessing the array s1 dot array of 2. I am trying to print. Yes, it is not reporting any error, isn't it? Now I am running this. You could see array of 2 is 3. It is printing. Okay, this is 0th location, this is 1th location, and this is 2th location, 2nd location. Isn't it? It is printing. Even if I try to change the value, like s1 dot array of 2. Now I am changing that to 10. It will get, it is modified. Okay. Now you could see after that the array element, if I try to print, it will change that. So that should be avoided. For that we can go for, you could see array of 2 is 3 and I changed and it is printing. So this is my original stack. Okay. And through another class, this is another class where main method is there. This is the user of that stack. The user is changing the value stored inside the stack, but that should not be done. It should be protected. Only through push and pop they can change the value of the stack. So now how I can change? Instead of this default, now I can make it private to this class. Private int array. Okay, if this array is made as private, now if I run this program, you could see automatically error is coming. Stack1 dot array is not visible here. This is another class. So private variables are visible only within the class and accessible only for the own methods, own class methods. Okay, so this is how we can protect the value. Some values we want to protect for outside access. Only the methods they can access. The value they should not change. Like some basic salary component, DA percentage component, okay, some mark value, something we want to protect means we can make it as private to the class. Okay, only through this pop and these class methods, only through those methods only we can change the values. Directly we cannot change the value if we make it private. Okay, so that is the job of access specifier. When I am making it public, yes, in that way also it is accessible. Instead of private, if I am making it as public, now you could see that error will disappear. You could see the errors are automatically disappear. Okay, because this array is a public variable accessible from anywhere, even outside the class. Okay, but default if I am giving means class of same package only it is accessible. Package concept we'll be seeing after this. Okay, so when we see package, once again we'll be revising these access specifiers again. Inheritance concept is coming. Parent class, child class. In that way we are having that place also we'll revise this access specifier. Okay, because this protected keyword come into effect when inheritance is there. Parent class, child class, that relationship is there, then protected keyword will have some effect. Okay, all the protected variables and methods are visible only for the child class. Same class and also its child class, not for other classes. Okay, but default is visible to other classes also, but not outside packages. Okay, but public is visible even for outside packages, anywhere. Okay, so that is the difference between these access specifiers. So simply you can remember from private we shall start. Private members are visible. Members means it can be a variable or it can be a method. Okay, private members are visible only inside the class. Okay, then protected members are visible inside the class as well as in the child class. Okay, and then default members are visible inside the class as well as outside the class, but within the same package. You can think of package as a folder. In the same folder, all the classes are there means it is visible in all the classes. Another folder is there. In that I have another set of classes means that default members are not visible in another folder. Okay. And public members are visible in all places. Okay. So while designing the program itself, we have to be careful. Okay. That data type is publicly accessible or default access or protected access or private access. Accordingly, we have to give the access specifier. Okay. So I hope you got some idea about access specifier. And next, static variable. So static variables are, so you could see, normally we'll give int a. So by default, I'm not giving anything means it is default category. And I am making it as static means no need to access this through the object. So here you could see use static. And normally to access the method, I should give object dot method name. Okay, so that is how we are giving here. You could see s1 dot push, s1 dot pop. Okay, but here you could see method is a method, met is a method, but it is a static method. So directly I am giving met of 42. I am not giving any object. Object dot met 42. Okay, static methods can be directly called without creating any object. Okay, so while running this program, you could see first I run this. You just check which is getting executed first. So just analyze this program. Static can be given to variables, methods, and normally to any blocks also. Like this is not a method, but simply a block. One open curly bracket and one closing curly bracket. For this also I can mention static. Okay. So when I run this program, which part is getting executed first? Normally main is the first line that is executed when we run the program, isn't it? So essentially we'll be giving main as static. So that is searched for to get executed, isn't it? While running the JVM, search for where is main. But the general definition is all the static members are executed as it is. Okay, wherever static is there, that will be executed. So static int a equal to 3, that is initialized, and b is also checked but no initialization, though this is simply skipped. And then method. So this is the static block that is getting first executed. Static block initialized, and b value is assigned. A cross 4, 3 into 4, 12 is assigned to b, and then it is trying to display x value, a value, b value inside this method. So when this method is called, it is called here inside main. Okay, so now I am running this program. You could see static block initialized, then x value, a value, b value. So you could see b value is coming here means what is the meaning? Already this has been initialized. So when we are starting this running, the execution of this program, first a value is initialized, then this static block is getting run, b value is also initialized, and then main is running. Inside main I am calling met, and met is coming, it is displaying x value, a value, and b value. Okay, so this static variable is assumed as a global variable here. So a value equal to 3. So if I am using a normal int x equal to 3, here I cannot give. Okay, so int x equal to int x. For this I am giving use static, use static object name, use static. So this is the normal way. How do we use? U dot x equal to 3. So in this way we'll assign value, isn't it? And this is u1, and another object I am creating, u static u2, another object. Now u2 dot x equal to 5. Okay, u1 dot x 3, u2 dot x 5. Okay, now I am printing this. System dot out dot println u1 dot x. u1 dot x is u1 dot x. So this value I am printing. Next, u2 dot x also I am printing. u2 dot x. So this is also I am printing. Okay, so now what will happen? It will print 3 and 5. Okay, so now I save this program and I run this. You could see static block initialized, and then it is executing main, and then it is calling method u1 dot x 3, u2 dot x 5. Now I am giving u1 dot, what is the name of this static variable? A. u1 dot a is equal to 10. Okay, u1 dot a is equal to 10. So what do you think? Here a value is 3 and here I am changing it to 10. Okay, and u2 dot a. Okay, u2 dot a I am making it 20. So now what will happen? This I am expecting that this will print 10 and 20. u1 dot a, u2 dot a. Okay. So u1 dot a I have given 10, u2 dot a I have given 20, and I am printing both. Here when I try to print u1 dot x, u2 dot x, 3, 5, these are printed. But 10, 20 now I have given, and I am expecting that is to be printed. So now we shall check what is happening. u1 dot a is also 20, u2 dot a is also 20. Why? Because static variable, only one memory location is created for all the objects. Okay, it is global. So the latest value what I am storing in that, irrespective of the object count, that will be there. This final value is replaced in that memory location. So for this case, normal int x, u1 separate memory allocation, u2 separate memory allocation. But here for static int, one formal memory location, u1, u2, u3, u4, anything you create in the same location, it is changed. Okay, so you can essentially think it as a global variable. So as I told, counters, how many objects are created for this class? I want to count, means then I can use this. How do I make it? I simply use this b as a counter. Okay, so how many number of objects created in each of these constructor? I am giving b plus plus. Okay, so that will give me counters. So in this way, your visitor number 1,20,005. Likewise, some websites are telling, isn't it? Your visitor number. So that is essentially achieved through this static variable. Okay, so this is how static is working. Okay, static is applicable to variables, methods. If it is applicable to variable means it is like a global variable. No separate instance is created for each object. Okay, it is common for all the objects. And if it is given for method means no need to call that method using object, or simply using the class name I can access. So use static. use static dot method. So in this way I can call this method. Okay, and static can also be used to blocks as like this. No need to call this. Automatically this is called before even main is getting executed. Okay, so when we see the result, static block initialized, that is the first thing, then main is getting executed. Okay, so this is how static is working. Now final variable. So in the same example, I'll show the effect of final. So inside this method, I am trying to change the value of a. Okay, a equal to a plus 2. Yes, it is accepted. But if I am having a final variable, final int max equal to 999. Okay, this is fine. Usually Java follows a naming convention that all final variables are should be given in capital letter, full uppercase. Okay, so that common thing is followed. But even if I give small also, it accepts, no problem. So it is a good practice if we follow full caps. We can quickly identify this is the final variable. We cannot change it, not variable. Final, what to say? Variable means it is changeable, but it should not be changed. That is the meaning. Max equal to max plus 2. So when I give, immediately it is reporting an error. Cannot make a static reference to the non-static field max. It should not be changed. I'm giving wrongly. Okay. So it should not be changed. Okay. So final variables are final. That's all. Assigned means so. Same way, final methods also I can create. Final class also I can create. Okay. So the effect of final methods and classes we shall see when we see inheritance concept. Okay. So up to now, final means like a constant. No, we cannot change it. Anywhere in the program, some value like interest percentage, interest rate. Okay, for a bank, that should not be changed. Outsiders should not change that value. Means they can make it as a final variable. Okay, so that you can remember. So then nested and inner classes. So we can create inner classes also, class within class. Okay, so how do we create that? So you could see, so I'm having a class called outer and one variable for outer x, and one method for that. Inside the method, I am creating object for inner class. So this is inner class. Inside the class, I am having another class. Class inner void that is having a method called display. Inside that, I am displaying outer variable. So this variable is visible inside in the full class. Okay, this class is also inside that, so it is visible here. But if I am having a variable here in inner class, okay, I am having inner underscore y. Okay, inner underscore y. I am having a variable like this too. Like this, I am having something means that is not visible outside this. So I cannot print. So in here, simply I can call inner dot display, but I cannot use this inner y directly without using the object inner. So here I can use inner underscore inner dot inner underscore y. Yes, I can do that. I can change the value. This is perfectly valid, but simply inner y equal to 5. If I give, it reports an error. Okay. So using the object only, I can use. Okay. So now I simply run this program. So main is not written here, only One outer class and one inner class. That's all. Main is written separately. So here I am creating object for outer class and I am calling outer class method outer dot test. So now I am running this. It is displaying display outer x equal to 100. Okay, so that is what I tried to print, isn't it? So out test is called, and in that I am calling inner dot display. Display method is called. Inside that what I am printing outer x. Additionally, if I am printing inner y value. So here display, inside display inner underscore y. So if I am displaying that inner underscore y, that is getting printed without any difficulty. So you could see both the values are printed. Outer x, inner y. Okay. So here I didn't give any equal to symbol. Here I am giving equal to symbol. Now it is okay. So outer x, inner y, both are getting printed, isn't it? But though we can use inner classes, it will create some confusion. So generally, inner classes are avoided by programmers. Okay, we have to carefully give the code, otherwise it leads to some confusion. But this concept is given because of its usefulness in event handling. Okay, advanced Java concept. Okay, so in that case, this inner class concept, anonymous class concept are very useful. For that purpose, it has been included, but generally for normal purposes, no one prefer to use this nested class concept. Okay, so wherever there is a specific need, yes, we can go with that. And the other thing is string class versus string buffer class. So string variable directly we are using, isn't it? Like, yes. So you could see string like a primitive data type we are using, but actually it is a class in Java. Okay. So string S1, welcome. String S2, Java, programming. String S3, S1 plus 2 plus S2. So these are all several ways how we can initialize values to string. And I am printing all these. And we have three methods, default methods, that is applicable to all strings. Equals method, it returns boolean. Length method, that gives length of the string. Char at method. Char at method takes one integer value and it returns a particular character in that location. Okay, so in this you could see. So I have applied S1 dot length. This is 1, 2, 3, 4, 5, 6, 7. And S1 dot char at 3. 3 means 0, 1, 2, 3. Welcome. C will come. And I can apply equals. S1 dot equals of S2. Okay. If these two are equal, then I can print both are equal. Otherwise, I can print these two are not equal likewise. It returns a boolean value, true or false. So now I simply run this. You could see welcome Java programming, welcome to Java programming, length of first string 7, char at index 3 is C, and these two are not equal. Okay, so this is how we can manipulate strings. And there is another class called string buffer. This is similar to string, but the main difference is string class has been created like with some restrictions, but string buffer to include big strings. Okay, we can keep on adding like one paragraph also I can keep on add, that will automatically extends the memory. Okay, but string object is limited, it cannot automatically extends memory. Okay, so that is the difference. All the methods that we are using with string, the same we can also apply with string buffer. Okay, so in today's class we have seen recursion, already we have seen, And we have seen how to create command line arguments, variable length arguments, access specifiers, static variable and final variable, nested and inner classes, and string class versus string buffer with equals, length, and char at methods.